And all of you out there in virtual land, I'm always happy to see you. So let us move on. So today we're going to do the liver, we're going to do the gallbladder, and probably a fair amount of the small intestine, and that's what we have to cover. Remember, we won't see you till Monday. I'll be here Wednesday, but not Friday, yes. So just remember that so you can get it. Hopefully you can take Wednesday afternoon off with my, tell Dr. Dressy isn't the lecture. So it's on my set, so he may go for it. He may not. We can only hope. Here we go. So the liver. I mean, the stuff that you should have had, or and whether you did have it or not, I'm not going to ask you about. I'm not going to cover stuff. I'm not going to ask you about the anatomical stuff. I mention it in passing. So the liver is really very large compared to, I mean, really predominant. You opened up that mouse or that rat, you saw it's the whole internal abdominal cavity is all liver. We're not a whole lot different. Okay, that's there. It is, the color has to do with all the blood that goes through it. Has a tremendous amount of blood supply. These are extraordinarily, for a gland, and we'll talk about that a little bit here. We're going to talk about two areas that are extraordinarily rapidly reproductive. One is in your small intestine, and the other one is here in the liver. That's why we can do partial live liver transplants. When years ago, okay, we only could do cadaver transplants. And I mean, and obviously, as you might expect, there'd be a shortage of the likelihood of finding a compatible cadaver that you can get to, because you had about 24 hours to transplant. It's very, very difficult. They formed a network here, started in Pittsburgh, called CORE. So we use the acronym CORE Network, which were the O stood for organs, because this is effectively is the transplant capital, surely of the United States. And because of that, a lot of other big medical facilities followed it. But it was very, very difficult when cadaver liver transplants started. Really, a lot of the transplants come from here. So you're in school here or living here, depending on where you're from, in a very interesting area with regard to that. This is the anatomy. The liver is all the same. The right lobe, the left lobe, the quadrant lobe, who cares? They're all the same. Any piece of liver, when we want to find out if somebody has hepatitis or cirrhosis, we do a liver biopsy. Any piece of liver is identical. So you take a little sample, like a tiny little piece out of the right lobe or the caudate lobe, they're going to look exactly the same. They're divided by little pieces of peritoneum. They're the remnants of the umbilical cord. There's not a whole, and that's so anatomists form these lobes. They're all the same. The functionality of the liver is all about these lobules. The cells are identical. The lobules are shaped identically. If a liver is damaged, a lobule will lose this very remarkable, very consistent hexagonal shape that you will see very shortly. And what happens is it starts to form scar tissue. If the scar tissue persists, the more scar tissue, those cells are going to die. They're going to be replaced by fatty cells. We have a word for that, cirrhosis. Okay. You just say, I got to check. Yeah. So all of those things tell you something. So what happens is when the liver does that lobule, of which there are millions, begins to deteriorate. As it begins to deteriorate, it becomes fibrous. Then the liver's all made out of fat. And so eventually all it becomes, it loses what it does and becomes just fatty cells. And effectively, when you have enough of those, that's what we call effectively the end product, not of just being inflamed, a la hepatitis, but cirrhosis means that your liver is scarred and is turned really into fatty material. The reasons that it occurs, the reasons why people have liver failure and have liver damage, unfortunately, still the vast majority is substance, alcohol. Any infectious disease that affects the liver, toxins can affect the liver. They all can. When you hear about someone with mushroom poisoning, liver. Okay. When you hear about hepatitis A, we had this in micro. Whether you covered it in your micro, I know it's in mine. Hepatitis A is a fecal to oral virus, something you get from food you consume. Hepatitis B and C are bloodborne. There's other letters that are there. Some of those hepatitis infections are they're all viral, but they are some are fecal to oral, some are bloodborne. So it's not the only ones. There's more. If you're curious about that, and depending on where you go, or what your lives are like, you may have to become more familiar, choose to become more familiar with those kinds of things that are there. So it's fascinating, and it's so vital because it does everything. It makes clotting proteins. It makes all the proteins in your blood. It makes all the fats. It refines them. You're going to see a laundry list as long as your arm of stuff the liver does. I was joking with the other class. I mean, I have a laundry list of stuff I have to do at home. If I could just assign it to my liver, it would hardly make a dent. You know, it's really extraordinarily busy. And the tragedy, and this is the other thing, when it becomes fatty, even if, I'm not talking about someone who's got cirrhosis of the liver and is probably going to will have a tough time surviving and is likely going to need a transplant to have a chance at surviving. But to understand when we used to do all those things about BMI, basic the basal metabolic index, basically it's a measure of how fat you are. We used to say if somebody was worked out all the time, they were very muscular, you had overweight, maybe they were, versus over fat. Okay. And the idea is if you were in that 35% or above BMI, that meant 35% of your body was fat. That's a tremendous burden on your liver. Your liver has a lot of functionality, but the more fat that you have, even though the liver is mostly fatty tissue, these are the wrong kinds of fats that are there. And really, this was the big worry for a lot of people. And unfortunately, we have a great deal of obesity. I've been part of that for a long time. And there's all sorts of interesting things where we underestimate, maybe the wrong word, take our liver for granted. So you're all young. Don't. Take the point. Okay? For everybody going forward. Not just for you, for people in your orbit, for people you're fond of, all those kinds of things that are there. Another word about alcohol. How much does it take to get alcoholic hepatitis and eventually lead to alcoholic cirrhosis? It is not quick. Think of this. Imagine you would have to drink every day for 10 years one of these three: 6-pack of beer, bottle of wine, bottle of booze. 10 years every day. 3,650 days in a row. Or effectively that. Probably the only reason you wouldn't drink on a given day is you were so drunk you had to sleep through the whole day. That's a lot of serious drinking. So it's I'm not trying to be preachy about it for someone who drinks very, very infrequently, but it's a toxin. Okay, anything with moderation helps your circulation. Without moderation, it's a big problem. Enough said about that point. So everything in the liver looks the same. They're called lobules. You'll see them in a second. The cells are identical, and it's unique. Okay. You might remember we talked about capillaries. These are called sinusoidal capillaries. Most capillaries have tiny little clefts for water-soluble particles. The kidney has bigger ones because it filters. The liver has massive openings between the cells. It's designed that way because all the blood that's coming into the liver from the venous side is receiving uniquely an organ receiving venous blood. That's the blood from limited with nutrients such as they are from the stomach, small, mostly, large intestine, a little, that have to be processed because in there are toxins that we eat, bacteria, viruses, other microorganisms that potentially could cause us trouble. All sorts of elemental toxins. There's so much stuff in the liver that's going in that blood, rather, the liver has to deal with it. The unique circulation is from the stomach, small and large intestine, all of that blood that's coming out of there. Remember, The big fatty stuff is going into the lymph. The liver will have to deal with that later. But the blood itself, everything is dissolved in the plasma, has to go through the liver, and a lot of it has to undergo all these processes that you will see very shortly. Effectively, it leaves the capillaries in, let's say, the small intestine or those other areas, forms a vein called the hepatic portal vein. That portal vein goes into the liver and forms capillaries, hepatic sinusoidal capillaries that, as you will see by the illustration, just encounter tons and tons of liver cells for processing, toxifying, processing, making proteins, making complement, making clotting factors, you name it. Okay? Doing all the things the liver has to do. In order to do that, it needs an oxygen supply that's fairly generous. So into each corner, each of the 6 corners of this hexagon, you will also see an artery, or in this case, an arteriole, a little branch, and a portal vein. All of that blood, the arterial blood that's becoming a vein, the venous blood that's been processed, eventually flows into something called the hepatic vein, and that leads to the inferior vena cava. So you have 2 supplies coming in: venous blood to be worked on from your digestive tract, arterial blood to provide the energy source for it. In the meantime, back at the ranch, those cells not only are doing all that job, they're producing not only waste products, but they're producing bile to help us digest fats and to get rid of the breakdown products that we have a hard time getting rid of otherwise from red blood cells, which we have amazing amounts of, that we keep breaking down and building back up. The part we can't recycle, you remember this from blood, is that heme unit. And so what do we make from it? Bilirubin. Okay, bilirubin we excrete both in the feces and in the urine. It gives it the distinctive colors that we see that associate with that, because all that pigmented material is doing that. But the longer we hold on to it, the bigger trouble it can cause us. So you will see that. So they call the combination of the hepatic artery, the hepatic portal vein, and the bile, the smaller versions of all of these, the venial, the arterial, and the little ductule. We call that a triad. 2 things going in, 1 thing going out. Here you can see, I don't get a lot out of this from its positioning, but it's big. Here I don't get a lot out of this. This is all the anatomical stuff. Here's this triad. We call this the porta hepatis, the port into the liver. You have the very, very large hepatic portal vein, the fairly large hepatic artery, and the bile coming out. And effectively what happens, what the gallbladder does, is it plays a non-essential role in concentrating and storing the bile. We will get there. And after everything is all said and done, then you're going to see it exits by way of a vein here that joins the inferior vena cava. There's hepatic veins here and here from one side and the other side that join. That's the blood that has been filtered, processed, dealt with, detoxified, whatever word you want to use for it. This is what they look like microscopically. I have the other PowerPoint from previous textbook, Marie, which has a little bit more, maybe a little better, not substantially different. I'll show you illustrations. This is schematically the hexagon. Each corner of the hexagon has that triad. They're showing you the largest vessel, which is the branch of the hepatic portal vein, flowing in over just all of these things. Mounds and mounds of cells. Okay, all of those cells are filled with a variety of chemicals that are designed to detoxify it, convert nasty things like nitrogenous wastes into something we can get rid of much more easily. We take off the amino group of most amino acids we ingest from all the proteins we eat, and that forms something called ammonia. Ammonia is a horrible toxin. Okay, the liver takes a couple of ammonias, get this, mixes it with something else that's pretty versatile, carbon dioxide dissolves in the plasma, and makes a chemical called urea. Why is that so much less toxic? It's 100 times less toxic because it's 100 times more water soluble. What your body does when it detoxifies, the vast majority of it, 90% or so of it, of materials are detoxified in the liver. Much of them are made more water soluble so we can excrete them more easily in the urine. That's why what do they do when somebody comes in here and think about an overdose? I mean, you can certainly do blood tests, but you immediately dipstick of urine and do a quick dipstick test of the urine. Are they on coke? Are they on speed? Are they on heroin? Blah, 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 blah. And then from that gives you a clue. Then you wait for the blood test to come in and you can know specifically what they're on. It takes a while to do a hair sample, which are very reliable. Don't look at me. I didn't have to test me. I didn't have a DUI or anything. And anytime I was driving under the influence, that statute of limitations has passed. One time. Don't judge me. It wasn't under the influence of alcohol I was driving. Years ago. Woodstock, that area. Didn't miss a day of smoking pot for 7 years. Just 7. It helped me concentrate. And really, music always sounds good. Don't judge. Why did I stop? Doctor. Once I start, I tell her, when you're a student doctor, there's somebody else who's ultimately responsible. I had the ultimate responsibility, even as a resident, when you have attendings who are effectively you're working under their license, under their auspices. I could accept the fact that I made a mistake because we all make mistakes. I would have a hard time with making a mistake and having it impact somebody else because I was. So I never did anything like that. I mean, I basically stopped. You never want to be impaired taking care of people. Yeah. Moving on. This is actually what it looks like here. This is where it's flowing to. We call this the central vein. That's going to form with all the other central veins. Eventually form what we call the hepatic veins. Notice the word portal is not in there, and that's going to lead to the vena cava. So when this is irregular, we really get a lot of information from it. Another view. So you have the artery coming in, nutrient and oxygen, hepatic portal vein, all the stuff it's got to work on, flowing to the central vein, and the bile going in the other direction. So that, and just walls and walls, mounts of these cells, and they're reflecting the sinusoids as these large openings. And yes, there's other kinds of, like there's antigen-presenting cells, Kupffer cells, sampling the stuff. So our immune system, if necessary, can respond to it. There's a lot that goes on. This is its liver's to-do list. Mine is not that long. Glycogen from glucose. Understand, we have a limited ability to store glucose. Glycogen is only stored in the liver and in skeletal muscle. We talked about this already as an emergency supply. When glucagon is released, we want to put, for an emergency, we have to break it down. So now, not only does it make it, it has to have the ability to convert it back to glucose. This is called, fancy name, gluconeogenesis. It does that too when we need more glucose. Not that you have to know that. It breaks down fatty acids. They can be an energy source when we're running out of energy as well. That's kind of the goal of the exercise when you're doing effectively like on a treadmill or a cross trainer, what's called a fat burn. You're trying to flip into breaking down fatty acids. It's all the stuff that moves fats, makes membranes, converts excess carb. What do we do with excess carbs? I'm an authority on this. Okay, your body, you have 1 minute to use that ATP. If you haven't used all the ATP you made for whatever you had for lunch, it's going to become fat, period. Until you need to use it. And that's why we always talk about, I mean, if you're going to do a calorie counting diet, most of us with ordinary activity, typical activities use about 2,000 calories a day. Ingest 2,000 calories a day. That's what calorie counting is about. You want to lose, ingest less. You want to gain, ingest more. That's all. And tailor your activities to it. Some people do metabolic rates, all that stuff. There's some differentiation that goes on. Uh, this is what I was telling you about with the amino acids. This is the urea, making proteins, making vitamins, making other amino acids, taking care of red blood cells, all the detoxification, I mean, et cetera, et cetera, et cetera. Tremendous amount of stuff that it does, and they summarize it here for you. So you may or may not find that interesting, but it certainly should be useful. So the liver, we can't live without. As you can see, it's capable of regeneration if only we have a healthy remnant. That's so that has changed things because forever it was cadaveric livers. And these are just some of the things since I've been teaching this and have changed over the years. Problem with liver cancer, when it's a very because all of your blood goes there when you have a cancer that metastasizes, meaning it's spread, they spread by way of the bloodstream frequently. Once they're in the bloodstream and they get to the liver can deal with, with occasional cancer cells. Eventually, they'll colonize, and now you have this. And at that point, I don't know any way to say it, the person's going to die. I told the other group about the one I saw an autopsy, the only one I really saw start to finish as a student, not even a resident. And the gentleman was homeless, had died because we had a lot of homeless folks in the area where we were going to school. And he was an alcoholic, and he died of the chemotherapy in the attempt to treat the liver cancer. It destroyed his lungs. That we saw the lungs were just gone. But when they opened up and pulled out the liver, the pathologist said to us, even though he died of the lungs, the underlying disease, the liver cancer from hepatitis, undoubtedly is what caused it. And that liver was like you had liver, and in between, it's like somebody shoved non-liver stuff all through it, like it was just littered with tumor. Awful. And I can recall it very acutely. It was about it was one of those deals. Hey, everybody should see one of these. If they have one, and we ran. There was the hospital next to where we were going to school. We were able to see this. So we know all these things. You can donate part of your liver. It's the shortage is because they're cadaveric livers. But now we have when they say extracorporeal, that means out of body. Okay, device that actually is able to do the job. And look what's interesting. They call this is. I mean, this is where medical science is trying to go. When eventually you're going to start hearing like things about organ farms and growing things and where stem cells are heading, and whatever you're feeling ethically about it is, or people's misgiving, it's going there. It's one of those things that starts rolling. It's hard to stop. So we have artificially made stuff. When you talk about dialysis, it's artificial. You have an artificial system of filtration of the blood. That's all. It's getting rid of the stuff that's your kidneys because your kidneys can't do it anymore. Here, you're doing it because you have something that's artificial and you have something that's human tied together. So that's very, very interesting. Passes through where the toxins are removed, the really important job that your liver has to do, and then stuff is added from the liver that, like the bile, that's going to be necessary. And so here's the bile itself, continuously secrete about a liter a day, about a quart a day, and it's mostly water, but the salts help us emulsify or break down fats. Fats, as I mentioned before, fats basically are just kind of cuddled together. We have to have something get in between them. That's bipolar. That's what bile is. It's also one of the ways we use cholesterol. Okay, really important digest, and we recycle. Got a fancy name. It's called the enterohepatic pathway. We recycle about 95% of it. Years ago, when they started doing, so 95% of this, we use cholesterol here. The original cholesterol medicines interfered with that. It was a problem because it really hurt the liver because they really impacted the liver by not allowing it to do its job. And that's the trouble with like everybody's familiar with Ozempic and all these wonder drugs. It's the thing people went to bed for years. I can take a pill and I will lose weight, or I can take a shot and lose weight. We have no idea what the long-term complications of these things are. That's the problem with wonder drugs. People think they're a panacea. I call them wonder drugs not because they're wonderful, because I wonder what's going to happen 10, 20 years from now. The people use them, all of a sudden, they've got this cancer, they have this disease, they shorten their lifespan. You never know until after the fact. And I can tell you so many examples of these over the years that are there. And so here you're getting rid of the heme that you can't tolerate. And when it's blocked because of hepatitis, because of cirrhosis of the liver, because of liver failure, liver cancer, or it's blocked because the gallbladder makes gallstones and it gets stuck, then effectively it backs up into the bloodstream, and these pigments, they manifest themselves as yellowing. We have a name for it called jaundice. We used to see that all the time, yellow fever. Okay, same idea, because that particular virus impacted the liver. Okay, and indeed, hepatitis C, if you didn't know, which you wouldn't know unless you were in my lab, maybe, because you saw it in your micro classes, other than mine, did you mention that hepatitis C is a flavivirus? That's a virus. Flavus means yellow. So that yellow fever, hepatitis C, Zika, dengue, they're all in that category. West Nile. They're in that structure. Many of them cause hepatitis. It happens to be hepatitis C. Hepatitis B is in a different category, by the way. So all these things are part of it. Hepatitis, inflamed, lots of different types. Some are asymptomatic carriers. It starts like the flu, okay, in some people. And these are the types of things when your liver doesn't function, yeah, rash is possible, upper right quadrant pain, changes in urine and feces, remember the coloring involved with it, and then the jaundice that can occur. And really, the white of the eye is a classic area that goes lips, white of the eye, very distinctive. Very, very distinctive. Okay? And so, and again, it depends. Again, they're not all bloodborne. They're not sexually transmitted all or dirty needles. The one that affected closer to here than any other was hepatitis A. There was a major outbreak that infected over 1,000 people, killed 4, right here in Beaver Falls, PA. It's a restaurant that was in bankruptcy and now died, called Chi-Chi's. They still make the salsa. Don't worry about it. It's fine. Okay? Chi-Chi's up at Beaver Falls was right off the turnpike. Imagine when you have a restaurant that people go to when they're traveling, how hard it would be to trace the contacts. And they got that from green onions that had not been power washed properly and had hepatitis A, fecal to oral. Don't be shocked. It doesn't matter. They came from Mexico. It doesn't matter. If they came from California, it wouldn't matter. They pick them, any of them, things that they gather in the fields, be they in California, Mexico, wherever they're produced. The workers who pick them up, here's a clue. There's no porta potties in the field. Not in the U.S. either. That's right. So what do you have? So by law, you can break the law or have ineffective machinery. You have to power wash. So you go out to buy green onions at Walmart. They come from Mexico. They are supposed to be power washed with water to wipe off all that debris. You take care of it. Since I didn't see them do it, I washed them. All fruits and vegetables if you're not doing that, probably should be doing that. That pre-washed bag of lettuce, did you see them wash it? I didn't. I wash it. That's why the good Lord made a salad spinner. Oh, that's kitchen equipment you got to use. We take those on vacation. We're a little. Did you pack the salad spinner? It's like the Brita filter. Got to pack that. Got to pack the salad spinner. I guess it's just us. Okay. Don't say I didn't warn you. So all of these, yes, they're immunizations, blah, 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 blah. Okay. Moving on, and let me show you the pictures really quickly in the interest of time. This is what I was showing the other group. It's the same kind of look. That's that enterohepatic. You don't have to know about that system. It's just the way it works. But this, I mean, it's a very good illustration to show you three incoming. It's almost like walls of these identical hepatocytes, all flowing here and eventually leading to the inferior vena cava. This is really. It's just the way I describe the blood that comes in is like percolating through. It's like filtering through, just like lymph is filtering through. You have a lot of inputs, six inputs, all heading to one output. So it's going to get processed in its journey, so to speak. The gallbladder is non-essential. It is a sac. And its whole job is to concentrate the bile. We don't need it. When flu goes into your small intestine, the signal goes by way of cholecystokinin. Cholecysto is the name we give to the gallbladder. When it doesn't matter if the gallbladder is there. It's helpful. The analogy for the gallbladder, everybody, is it's kind of like the oven. You can see it there. And they had the picture before. It's kind of like the overflow tank that we have for antifreeze. When you put antifreeze in your car, you put it in something that's separate. For years, we put it right directly into the radiator, and you couldn't, obviously, if you had to open up the radiator when it was hot, you could burn yourself very easily. That's the way we used to do it. Now they have these overflow tanks, and so that's really what the gallbladder is. It leaves the liver, it goes here, it's stored, it's concentrated. The trouble with gallbladder disease, depending on people, hereditary predisposition, age. My daughter-in-law had 2 babies by way of IVF. She had to have her gallbladder removed after the first one because those are high contents of fat products that really put your because estrogen and progesterone oriented based that are designed to really support the pregnancy and indeed create the ability to get to harvest the eggs that are there. And her, right after the first, my granddaughter, who's going to be 8, that's Malin, okay, is going within 5 days after that, she's still in the hospital. They had to remove her gallbladder. She had a lot of trouble with bleeding. She was a sick gal when all this happened. Much less problem with my grandson, who's going to be 5. That's Anderson, if you wonder where I get the names from. Tests. It's either that or the dog, the cat, etc., etc. Moving on. So we don't need that. Gallstones come from people who have certain types of diet. They're very common. When we think of gallbladder disease, upper right quadrant pain, typically in women between the ages of 20-40, fairly complected, recent pregnancies, IVF, overweight plays a role, absolutely, because their diet tends to promote, it's more, we anticipate, the diet tends to promote a greater amount of bile production or a greater amount of bile need. That's there. All of these things are part of it. So there's all sorts of things that we look at. It doesn't preclude it from men, but upper right quadrant pain in somebody like that it's like lower right quadrant is appendix till proven otherwise. Hot gallbladder is the other. I mean, these are the things we look at. So there's certain little indicators that are utilized that. So I want you should be familiar with that just in general knowledge. So all of those things, inferior surface, yeah, it does eventually merge with the common bile duct. And again, we talked about that a little bit in the entryway with the secretions from the pancreas, gallstones, variety of things are in there. The way we treat them today, there's medications you can use. The trouble with them, they just don't happen in the gallbladder. They can travel down and block the common bile duct. They can cause a backup of pancreatic secretions into the pancreas. All of these are big time problems. So what do? You can remove them surgically. Typically, that would be a last choice rather than a first choice. You can remove the gallbladder, which is done laparoscopically, small incision. That's what my daughter-in-law had done. They do something called lithotripsy for that and kidney stones. If you're unfamiliar with that, when someone's mildly sedated, they have them in sort of a specialized bathtub, okay? And they basically bombard it with ultra high frequency sound waves. The sound waves will shatter the stones, gallstones or kidney stones, to powder that can be more easily passed, whether in the urine or getting out of the gallbladder. So it's called lithotripsy. Litho means stone, tripsy means to shatter or to pulverize. So when you tripsy, I mean, tripsy is an interesting word we use in surgery. Litho just means stones. So that's where there's some stones. And there's that circulation where we recycle it. So with the emulsify, okay, and basically what happened, they're separating the fat system by increasing the surface area. Fat soluble vitamins. You got to know the big four. I'm sure you got a nutrition, A, D, E, and K. Almost all, 95% of these are recycled. And so upper right quadrant, usual, you can inject it with dye intravenously and take an x-ray. Ultrasound, you can use ultrasound to see it. Ultrasound with like looking at someone who's pregnant and trying to see the baby and how things are progressing. Ultrasound is different. When they're trying to do lithotripsy, it's a higher frequency. It's a more powerful amount of sound waves themselves are shorter and more frequent in length. So there's a way to do that. Science does. My colleague who was, I think he was just in here, Dr. Buxton, we did a course for the nuclear med majors, and now they've changed. They had someone to teach it this year. For about 3 years, he and I were teaching it called radiation biology. He did the radiation, I did the biology. So there's lots of different ways to treat them that are there, and they give you all that. And then lastly, a little sort of introduction to most of the small intestine. Effectively, everything that goes in there is chemical digestion. The only thing, they're not really mechanically digesting it. The mechanical is basically segmentation, moving it back and forth and propelling it along. Within about 8 feet, it's pretty much all done. All the chemicals that need to make this into a form that can be brought in across the lining are here. So within 8 feet or so, once it gets through the duodenum and effectively by the end of the jejunum, it has been chemically digested and then finally absorbed. So that's the vast part of it that's there, receiving the chyme from all of these structures, plus the liver and pancreatic secretions. It completes everything and it does the absorption. Absorption, there's very minimal amount of absorption in the stomach, minimal amount in the large intestine. The large intestine is basically water, maybe a few vitamins, a few electrolytes, non-essential tissue. We can do without it. The duodenum, when they say fixed, it's retroperitoneal because that's where the common bile duct is. You got to have that to be able to have it functional, as we talked about before. The jejunum is thicker and this is more active. That's because basically everything is accomplished. 8 feet. The last 12 feet is basically, did we miss anything? Peyer's patches and lymph are all about, is there some infection that's in there? Is there some microorganism? Is there a toxin or something foreign that may have to be addressed? And yeah, and effectively it's making sure, I mean, you've got all those extra feet. Okay, and that's the beauty of this system. For people with something called Crohn's disease, typically it affects all over the alimentary canal, but the most classic areas were in the small intestine. So with this extra material, you could remove parts of it if necessary. Even though it's essential tissue, you've got the better part of, 20 feet of it. So you don't need all 20. It'd be nice to have them. Okay, the mesentery and the ommenta are all ways that the circulation gets there. Nerve supply, they're protective. Everything has to be moist because it constantly has to move over one another. They have a nice illustration about it. This there. This gives you the idea of where's the small intestine end. Here's the mesentery. It's all blood supply, nerve supply, etc. The small intestine is all here, almost identical when we look at it grossly, and it ends here at the ileocecal valve. The narrowing is there as it enters the first segment of the large intestine called the cecum. It's the only one that has a name. All of these little sections, I'm sure you got that in anatomy, are called haustra. Tinea coli, haustra, epiploic appendages. Right? Ringing a bell? Yes? You didn't get that unit? No. Nobody's perfect. And here, this is the greater omentum. There's a one between the liver and the stomach called the lesser omentum. It's like an apron. And in surgery, we very carefully reflect this, take it out of the road, and put it back when the surgery is done, because without that, it almost like makes sure, because the thing that's horrible about abdominal surgery is we call it adhesions, whether the small intestine adhere to one another or they adhere to the side walls or in particular to the front wall. So you put this layer back over when you're done. That's why my 2 ulcer surgeries took 8 hours each. Slow, meticulous surgery. Less careful. Anytime you go into somebody, you make scar tissue. And the most unpredictable thing in surgery is scar tissue. You can do a bilateral surgery. In other words, they say do bilateral, not that you typically would do that, bilateral knee replacements. Okay? One side will be beautiful, the other side will have massive scar tissue. Every surgeon who does those procedures goes, why did this one have scar tissue? And the other, with no significant different history. They were not a known scar for them. Oh my God. Unpredictable. All of this are different ways. The small intestine has all of these wonderful ways to facilitate absorption. I would suggest that we start with this next time. The next time will be Monday, so see you then. Thank you. If I'm feeling ambitious, I might send a supplementary lecture sooner than later, so we may or may not start with that Monday. So let's just see how ambitious I am over the holiday. If I don't see you, have a great one. If I do see you, it means I'll see you in Micro Lab tomorrow.
Dr. Stone, is the micro